So now you can start, Lalit. Share your screen.
Okay.
Yeah.
Okay. So in this second lecture, we talk about some other functions of array and talk about some matrices. I may take help from the help section and explain
ललित
what we are
स्क्रीन
doing
थोड़ा
in
बड़ा
this
कर
section.
स्क्रीन बड़ी कर दो थोड़ा.
Okay.
हाँ ठीक है, now it's better.
So in this second lecture, we will discuss about some other functions and some uses of arrays and do some matrix operations. Or I may take help from help section to discuss about arrays. So I may take from first due to help section, which will find some other functions about array. So you can always take help and write the function name, which is array here, and a help window will appear here, which can explain what is an array. Array contains some objects, some data types, which is maybe integer, float, or complex, maybe, or this is the order of the array, that is the order of array, and this other options like what is the dimensions of array. That is initially you can use array command. This is the one-dimensional array. This ng min equals to 0. And just as I explained, these objects like parameters, vector objects, and other things. And also we give some examples here. So like this, there is some like other commands like empty like array. What is empty like array? That is talked about yesterday. Ones like, zeros like, and full like array, and empty ones, zeros, and full. And they also talked about order, okay? And here they talked about how you can generate array using NumPy. So the simple command to generate an array, and when it may contains these elements. If the first array contains only integers, so this is a homogeneous data type. So all the elements are integers. When you give one element as a float, all the complete array is converted to the float. That is 1.0, 2.0, and 3.0. And you can create, they all are the one-dimensional, or you can take two-dimensional array by writing this array with a square bracket, and inside the square bracket you can add the row or column element here. These are the two-dimensional array. And then also talked about the dimensions of array, that is you can assign that n dimension is equals to 2. And other types you can use like complex array. So you can write NP array, it's a one-dimensional array, and the data type is complex. So all the elements are 1 plus the imaginary part is 0. The j is here for the iota, like iota, 2.0, then 3 plus 0 iota. And other data types are called integers, okay, they are given. And you can also assign the matrix using the NP array and assign the np.mat, and now you give the elements like this in a string, that is 1, 2, and separated by a semicolon, 3, 4. So you can also generate a matrix using this. And other options are there. NP array matrix 1, 2, 3, and the other options. All other things you can generate array using this command. Other options like which we are using the identity, other options like the ones array, the ones like, zeros like, and identity matrix, diagonal matrix. So you can, if I use the diag command, so the other diag commands, that is you could help function of v comma and order of that matrix. Okay, so I can assign diag, okay, 5 comma like 1, okay. Integer must be 1 or 2b. Okay. So I can generate this. So the array contains the 0 element. Okay, assign this 4. So this is this command 4 0 4 and 1 0. Okay. 4 comma 5. This is the other options. You can generate the diag command, or you can, if there is a help section in the linear algebra section, you can always take help of this diag. So here there is the help option. So you can assign. You can go to the help option. But so the other arrange function you can assign. So np.diag. Okay. So let us say they give an array, a number of array, the number starting from 0 to 9 and up to 8, and then this is a matrix size is 3 cross 3. So then you can generate a diagonal array from this. So you can calculate what are the diagonal elements in this X array. So you can use the np.diag command and give the matrix that is X array into, and it will generate the diagonal array, that is 0, 4 and 8. Or this is the k comma 1, the order of the array. So you can calculate this matrix. This is 1, 2 and 5. The diagonal elements are 1 comma 5. And you put k equal to -1. So the lower half column, this is 3, 4 and 7. The diagonal elements are 3 comma 7. Or you can only generate arrays using diag command. Okay. This is the 0, 4 and 8 using the diag command. Okay, np.diag and np.diag. We are diagonal commands using the elements from that. So I could take help from that and generate an array. So let us say first we can create a 3-dimensional array. Let us say simply create an array whose elements is 0, 1, 2. Okay, this is a 3-dimensional or 2D. So you could use other options, and inside you could use comma. And again comma, third elements, and close this square bracket. Let us say 3, 4, 5 and 9, 4, 3. Okay, this is our array. This is our array A. So I can create a diagonal array from here. So you can use diag command, diag of this X. So diagonal elements of not X, but it is A. Diagonal elements of A are 0, 4 or 3. Or I can use the diagonal matrix from there using diag, D-I-A-G, and again using the diagonal elements from this array A. So this is the diagonal 3 cross 3 matrix which contains only the diagonal elements 0, 4, 3. Or you can assign some values to this. Let us say this is A1 equals to diag. And you can always do some mathematical operations. Let us say A2 is nothing but this is 4 star this A1. Okay, so the A2 is a diagonal matrix, so the diagonal elements are 4 times the diagonal elements of A1. So these are the diagonal elements. Or you can use directly to create a diagonal matrix. Or other ways I can create first identity matrix. Let us say B is nothing but B equals to identity of, that is 3 cross 3. So B is identity matrix, and then I multiply some elements to this. See, B1 is equals to some constant times, okay, this B. So B1 is a diagonal matrix, so those all the elements are 5, 5, 5. Or you can assign some values. Let us say B1 is 0 is equals to this is the first row, this is 5, 0, 0. And V1 the 2 is the last row, that is 0, 5, 0, 0, 5. You can calculate how to use some column vector from here. You can assign this V1, skip all the rows, comma, but only give my 0th column. So 0th column is 5, 0 is 0, or this is the first column and second column. Let us say B1, 2. So the elements are 0, 0, 5. So these are the elements which you can use to access these parts of this array. There are the other options like identity. There is ones, many times we need a one-dimensional array, or which contains some numbers, let us say 5, 5, 5, or a constant array. So we can generate using the ones command. Let us say we have an array C1 is equals to ones. You can give the elements here, is the ones. So C1 contains only the 1, and the length of the array is 10. You can calculate this length of this C1 array using the length function C1, which gives you the length of this array, how many elements are there. So this is a constant vector, or you can multiply this by some numbers. So we got element-wise operations, and we got 10 times of this, or we get an array which contains 10, 10, 10. Or initially, for initialization, let us say we are doing some calculations. So we first initialize values at 0. Let us say some variable is 0. So here we can assign that array using 0. Let us say using zeros command. So all the elements initially are these zeros of let us say 10. We have some initial values, and C2 is zeros. So you can now operate, now you can use some mathematical operations and then update these arrays values. So the initial value is 0, so the values changes as the mathematical calculation is done in the further steps. So these could be changed. Let us say we have some ones like commands, or zeros like, or let us say that commands first. Let us say d1 is equals to ones like. So ones like is this a data type you can assign here, and what is the order and what is the shape of that array. Let us say this 10. You can assign ones like array 10. This array is the total length of array is 10. This is ones like, so the element you put here in the second comma, after comma. So their array gets populated using, let us say this one. This d1 equals to array of only one values. Okay. So the ones like array, you can return examples. If you put some range and shape this function, so ones like is exactly what should be the order of that array. Let us say we have an X array contains these elements. So ones array is nothing but it creates a equivalent array, but all the elements are ones. Okay. So zeros like contains the one array which has all elements as 0. So move to there. So we can create, like we have some matrix. Let us say y1 is some array. You can create some array using some other functions. Let us say I have some values. That is y1 is equals to range. So this element is always there in the array, and this element is excluded. So n minus 1 element is there. So you can create y1 as an array which contains elements starting from 1, and the last element is n minus 1, that is up to 10. 11 is excluded from that. So you could create an array from this. So let us say y2 is equals to this y1 dot reshape. y1 dot reshape. This is 2, 5. Okay. So y2 is a two-dimensional array which has 2 rows and 5 columns. Okay. Let us say I have to assign or create an array which is equivalent to y1, but all those elements are 1 in this array. So I can create next array y3, which is ones like. Okay, ones like, but like y2. So y3 is an array. Two-dimensional array which has this order of arrays 2, 5, and all elements are 1. Or we can put if you have to multiply this array by some numbers, let us say some constant number, you can multiply this. Or if you have to create some zeros like array, so you can create a array initially from that values. It depends upon the size of that array and the shape of that array. This is a one-dimensional array. This contains the one-dimensional elements. Is two-dimensional. It gives the two-dimensional values of that array. And other options are there with zeros like, or you can create also do some mathematical operations like on matrix operations on them. So you can multiply them or subtract them using mathematical functions. So the basic functions are like you have to add, you must apply the plus operator. So let us say we have this y4 is nothing but this summation of this y3 plus y2. So the element wise summation is this, so this not this y4. So the element wise operation is this 1 plus the second element. So mathematical operation, and you can subtract those arrays using let us say y4 and y5 is the subtraction of these two arrays. So y5 is this element wise operation. Or but you could multiply these arrays using element wise operation. Let us see, I have to create element wise operation that's 1 to 1. So I can multiply these two arrays. So this is y6. You know this star y6 is y3 star y2. This is y3 and this is y2. So the multiplication of this becomes y6, stored in y6. So there is 1 into 1, 1 into 6, 1 into 2, 1 into 7. Okay. So this is the element wise operation. For matrix operation, there must be a condition that the number of rows in one matrix should be equal to number of columns in second matrix. So if I multiply these two matrices using the matrix multiplication commands like dot command, so this gives an error to me. So if I apply dot function and apply this y2 comma, this I can go to use y6 or y6. Okay. So there is an error that the shapes does not match. So shapes of the first matrix again 2 comma 5, and the second is again 2 comma 5. That's not aligned. Okay. So we know from matrix multiplication. So I have to change the second matrix of the first matrix to the transpose, take its transpose. So I can assign y7 which is equals to y6 dot transpose. You can use transpose and that open parenthesis, or you could use that dot key command to transpose that array. So this y7 is equals to this 5 comma 2 array. Okay. So could always check this shape is 5 comma 2. Now we can apply the matrix multiplication on that. So this is y, I have checked y7 to y2 comma y7, and I can store this in another variable called y8. So this is the matrix multiplication of these two matrices y2 and y7. Okay. And other operations like you could also use inverse of that, or you calculate the determinant of this matrix. So I could always use y9 is equals to determinant of this y8 and this y9 is the determinant of y8, and I can also use the inverse function. So there is a command called inverse. So I can use that for inverse. y10 is equals to inv of this matrix, this y8. So this y10 contains inverse of this function, the inverse of this matrix. Or I can also calculate the most probably we use the eigenvalues in our problems. So we can use matrix, this operation, that is EIG, this for the eigenvalue calculation. So we could use let us say y11 is equals to eigen of this y10. So this y11. So here the two results. It clearly shown that the eigen results are this. The eigenvalues are contained in this first array, and the corresponding eigenvectors are shown in the second array. Or you can separate out it like this y1, this eigen, this let us say eigen of this y10. Here in the square bracket you can assign 0th column, so 0th entries is this eigenvalues only, or you can assign y1, this 1 equals to, so this gives you the eigen. So you could always store them in another variable and use operations on them. So the other eigen vectors corresponding to those values. So these are some mathematical functions. Or you can arrange some other methods like list, because an array, if I talk about array, this is this bracket, this function array, and inside this square bracket, we can write some functions. So I can assign a first a list, and from that list I can create some elements for this matrix. So I initially create a list. Okay. So list 1 is equals to, here in the list, if you want a single line of code, actually you do not give 1, 2, 3, 4. You can use some loops or some functions here. So generally we use for loop for this. Let us say I am creating a list from cube of some numbers for this I variable in range equals to 10. Okay. So now I can assign an array from here. Let us say AR1, it is equals to only writing array command. Okay. Array of this list 1. Okay. So AR1 is again an array, or you can use linspace functions to create an array. So I can write it is L1 is equals to, it is defined in numpy linspace. You can assign equidistance points from starting from 1 up to 10. Okay. What number of points you should want is I want 10 points or I want 20 points. Okay. So L1 is again an array of equidistant points. That is this step size is the final value minus initial value divided by number of points. Okay. So you can assign those values and get those numbers from there. And use arange function. It is similar to that. You can use arange, that AR2 is equals to arange. Okay, 1, comma 10, comma 0.1. Okay, in AR2, there is another option. You can create 1 to 10 in steps of 0.1. So first point is 1, second point is 1.1, 1.2, 1.3, and up to this 10, okay, 9.9, because this is always not there in arange function. So this is up to 9.9. They are the two ways to create. So these are the all arrays you can create for your calculations and use them directly in the mathematical operations using inverse function and other matrix operations there. If you want another thing, so you could always check the help menu and always write help here and your function name. So you, let us say I am identity. So this gives me a full function. That is the Python has written the full function. You can always read that, and there is always example given there. So from example, you understood what these commands are, or always there is some other functions given here, and all the data types are given here. And we will not use the complex function, so complex matrix. Let us say we can create an array, complex array. So you can assign array. Let us say we have these elements, they are the real parts, comma. You can assign array type, data type equals to complex. Okay, with the number complex, you can generally use complex 128 bit, 256 bit, and 64 bit. Okay, you generally use the complex. So here complex is the complex matrix where we need the complex arrays. So here these values, how you can create these arrays like this. You want the dimensional array from the complex data type, or you could use integer, list, and then the other data types to create this array. So I hope so this is enough for today.